Alright, Speezers, we're talking about simplifying an expression, and then we're going to evaluate. To simplify simply means to combine our like terms. On the screen now, you should see that I've identified the terms with the orange, and I've identified the like terms with connecting them with the blue lines. Now to simplify them, I just bring them together. So if I have 6 positive x's and 2 negative x's, I need to remember that my zero pairs kick in. Anytime a positive of something and a negative of the same thing come together, they don't disappear or destroy, they just become a zero value or zero pair. So that means 2 of these negatives will cancel 2 of these 6's and leave me with 4 x's. I can do the same thing with 4 negatives and 6 positives is going to leave 2 positives. So then, to be able to write this in simplest form, I just write it together like so. At this point, you notice the cut allowed me to create the evaluation. And so what I did was I took this, x equals 3, and I substitute everywhere I saw x with the number 3, because that's what it's telling me to do. It has the same value, so I can switch them out. So when I solve this, I'm going to get 12 plus 2 is equal to 14. So at this point, for the first one, I have simplified it and boxed in 4x plus 2. And I've gotten my evaluate answer of 14. I've moved ahead, and as you can see, we now have purple on the screen, and that is indicating that I have distributed. So I have taken the number that's directly next to the parentheses, and actually I've taken the term, and I've distributed it to each term inside the parentheses. This is why it's important to recognize what a term is. So I took the positive 1 here and I multiplied by the positive x squared. Then I take the positive 1 and I multiply it by the negative x. Over here on the 30 expression, I'm going to take the negative 2 and distribute it to the 4 and to the positive x. Now that I've distributed and done the multiplication, I get 1x squared, because 1 times x squared is 1x squared. I get negative 1x, because 1 times negative x is negative 1x. And I carried everything else down without changing it. On the third one, when I distribute the negative 2, I got negative 2 times 4 was equal to negative 8. I got negative 2 times a positive x equals negative 2x. Now I'm going to recognize my terms. At this point, I went ahead and identified my terms by boxing them in with orange, and I simplified by bringing my like terms together, indicated by the blue writing. Now, at the bottom, you'll notice that I got a 0x squared minus 3 minus 1x. One thing to understand here is that if there's 0x squareds, we don't need to write it. So you notice in the answer, the final answer, I didn't list the x squared term. Also, to notice that the x here was last, but I listed it first. That's because a good standard to follow, it's not a requirement, but a standard to follow, is we write our terms in alphabetical order, in decreasing power order, with constants being last. There's exceptions, we'll talk about those later. At this point, I've now worked it out after substituting my x equals 3 by replacing every x with 3, and then treating it with order of operations, and the answers are now on the screen. Let's work on the fourth one. So I've identified my terms by boxing them in orange, including adding the positive at the beginning so I don't lose track of it. Now I've combined my only like terms in 2/3 x and 2x. At this point, I just brought down what I haven't been able to combine yet because it's not like terms. And I notice my x squared is actually listed last. But here's the exception I was talking about before. You got to notice how it's actually a term of negative x squared. Whoops, I thought I hit highlighter. It's a negative x squared, not just x squared. When the leading term would be 0, it's okay to leave this at the end. At this point, I've simplified it using fractions and boxed it in, and now I can move on to the substitution. And this is why most people don't like fractions, because there's a lot to do. First thing I did was I turned this mixed number into an improper fraction of 8/3. When I multiplied this 8/3 times 3, I remembered that this 3 is the same as 3 over 1. And when the numerator and denominator share a factor and they're multiplying, those factors cancel. That left me with 8 over 1, which is the same as 8. I then took 8 minus 1/2, which was 7.5, and then subtracted 9, and that left me with a negative 1 and 1/2. The other way I could write the same number of negative 1 and 1/2 as negative 3/2. At this point in math and moving forward, a mixed number and an improper fraction are the same thing, and we actually prefer improper fractions, and we'll be discovering why a little bit later this year. That does it for being able to simplify and evaluate with terms and like terms.